Okay, so hopefully you got a chance to try it as well and you got the same answers. If you're struggling with it, here's the method to go about it, right? So to find the maximum height it reaches, this time I will I tend to redraw it a little bit because this time I want to find a different final point, right? So my initial point is still there, but I need a final point somewhere over here, okay? So we'll redo our SUVATs variables here and write out the same things. Now the initial point, this time the initial velocities are going to be the same because that's the same initial point, but the final velocities are going to be different, right? So the initial x it is 10.392. I think that's what I got up there. Yeah. And because the same thing, there's no acceleration in the x, so this is not going to change. This is going to be the same. And I don't know what that is, right? So I don't know what that displacement is. So that's going to be question mark. I don't know the time as well. So we can look at this. So this is the same thing. This is going to be minus 9.8 over here. And the initial uy is also the same. We can go back and look at it, right? That's 10 sine 30 degrees. So that's, 12 sine 30 degrees. So that's just 6, I believe. Yep. So we've got that there. We can write that. And Vy, do we know Vy? So this time it's the final velocity at the maximum height point, right? So what's the velocity there on the y component? It has to be 0. So because yeah, we explained that before. So this is what we want. We want the maximum height. So we want the displacement over there and we don't know the time. Okay, so same thing. Well, let's if this is our aim, let's pick this side, something without a t. So that would be v squared equals to u squared plus 2as in the y direction. And I know, so this is 6. This is uy is, sorry, that the vy is 0. Uy is 6 plus 2 minus 9.81 sy. And I can rearrange that. So sy equals to 36 over 2 times 9.81. We plug that in the calculator. And I get 1.835, but that will round up to two significant figures nicely, and this is positive, so that makes sense because it's a positive displacement, right? So that's around 1.8 meters there, what we've found. So therefore, the max, so we actually, this is the math part, right? That's not the complete answer. Let's actually answer the question. So the max height, again, it doesn't have to be full sentence, but something that's comprehensible, okay, with the right sig figs, right units. And we can round this up with finding the time it takes to get there. So if you find one without an s, that will work. For example, v equals to u plus at, that will work nicely, I think. So put in your y's, 0, and u is 6 plus minus 9.81 t, and let's rearrange that. So I get 6 over 9.81. Notice the beauty of having things vertically. Everything is very traceable until you move the last step when you manipulate it. So it's very clear. So I get 0.61, let's say 612, and I'll go like, therefore, it takes roughly 0.661. I probably should have included that there, 61 seconds to reach the maximum height, something like that. All right, so do more practice. As you can see, it's very repetitive, and once you've done it once or twice, this scheme will always work. Okay, Just for completeness as well, just to show you, if you have time in the exam, it's a good way to check your answer with a different formula, right? So now that you have all the, so for example, the last part, try to use a different formula to try a different equation. For example, let's go with the other one that is S equals to U plus V over 2 times T, right? We haven't used this in a while. So let's give that a try and see if that works. So if I want to find T, right, for the last part, I have S, which I'm going to use from earlier, from the previous part, 1.8 equals to U, which is 6, plus V, which is 0 divided by 2, right, times T. And that implies T would be 1.8 times 2 divided by 6. So let's see if that works, right? 1.8 times 2 divided by 6. And I get 0.6 as well. I used the rounded one. I probably shouldn't be using the rounded one. So if I go back over here, I should be using 1.835. And I would get a slightly better 0.611, right? So I'll get 0.611 over here if I had used the slightly more accurate one over there. So that will give you confidence. So it's always a good thing to do. Decide to show you this as well, so for completeness. And yeah, good luck with it. Just plenty of practice and you'll master this in no time.